Hello, welcome to the next section. This is section 0.1.1. Actually, we'll be working on something called inverse operations. You're looking at a blank screen right now, I get that. But the reason for that is I'm going to tell you a little story. When I was teaching in Edina, and this was probably, I can't remember now, 5-6 years ago, I was on my way in from KS95. And KS95 had this problem that they went through. And when they got through with the problem, they said, if there's anyone out there who, or the people that write these kind of problems should be president of the United States. Well, I wrote in the next day and I told them exactly how to do their problem. Well, they started going through how to do it. They were reading my email on the air. And the lady got so confused by my email that she just said, you know what, forget it. It's people like this that should be president of the United States. So I now have a vote from a KS95 personality that I should be president of the United States. Yes, me, Mr. Anderson, president. I know that's kind of a scary thought. But here's the problem that they had shown us. And I'm going to go through this with you. I want you to grab a calculator and have it handy and go through this. If you don't have a calculator, pause the video and go get one. It's kind of a fun problem. All right. So here's what I want you to do on your calculator. Enter the first 3 digits of your phone number. So for example, don't worry about the area code, like the 952 portion, but the next 3 numbers. So if your number was 952-888-1111, you would enter at this point the 888 portion of that. So enter the first 3 digits of your phone number into your calculator. Now, I want you to multiply, so go times 35. It's important now that after every step I say you hit the button, the equals button. So you should have multiplied by 35, hit equals. Your third step, multiply by 300, hit equals. Your next step, divide by 7 and hit equals. If I go too fast for you, just pause the video and keep up that way. The steps are all listed here. Step 5, multiply by 40. Hit equals. Sorry, I didn't write that right there. I should have. Step 6, divide by 3. Hit equals. I must have got lazy. I'm not even hit equals anymore, but I mean to. Your 7th step, I want you to add the last 4 digits of your phone number. So, for example, remember my example one was 888-1111. So at this point, I would add 1111, but I would add it twice. So make sure you do that. Hit equals. Oh, I see I'm not lazy anymore. I put the equals button on there again. Your next step is to divide by 2. Hit equals. I know, it's a lengthy process, isn't it? Well, do you recognize the number on your calculator? If you do, and it looks very familiar, well, you did it right. If not, try it again. You'll get it. I'm going to come back to this example in a moment. But before I do, it brings me to what our lesson is about today. So, our lesson today, come on computer, keep up with me, is that we can each apply inverse operations to numbers and variables. Now, we're hitting this at a very beginning stage today, so I'm not getting terribly deep into it, but a little bit. So, let's take a problem 5-1, talking about inverse operations. Now, here's another mathematical trick. Go ahead and take your calculator again. Pick a number. Think of a number. It doesn't matter what the number is, but pick a number. Add 5 to it. Oh, by the way, that number you picked, you may want to write it down just like it says right here. Write it down. So, add 5 to that number. Double it. By the way, what does double it mean? Double means 2, that's right. Multiply by 2. Then, subtract 4. By the way, are you hitting equals each and every time? Because if you're not, your calculator won't do this right. So again, let's start it over. Take your number, write it down, add 5 to it, hit equals. Double it, which we just said means multiply by 2, equals. Subtract 4, hit equals. Divide by 2, hit equals. Then subtract your original number. Whatever was the original number, subtract it. What did you get? Well, if you did it correctly, we'll move this to the next page. There it is. If you did it correctly, everybody should have got the same answer of 3. It's magic, I know, it's just incredible. Actually, it's not magic. What it is algebra. What you did when you picked a number, and everyone picked a different number, and we don't know what number you picked, but you picked a number, so we're going to call that number x. When you then added 5 to it, you took your x and you added 5 unit tiles to that. You then doubled it, so instead of having an x plus 5, you now have 2 x's plus 2 5's, or another way of saying that is 2x plus 10. Then we had you subtract 4 from that. So we took these 4 over here and we subtracted it. So everybody was at 2x plus 6. You then divided it by 2, so you're back to an x plus 3. And then we had you subtract your number, whatever it was. What you ended up subtracting was the x portion of this, and everybody was left over with 3. Amazing, isn't it? I know. But that's how you can start to describe algebra problems with algebra tiles. You can take a nice, what seems to be a complicated problem, use algebra tiles, and solve it fairly simply. Let's look at another example. I think we have another example coming up here. This one here. Pick a number. Okay, you're going to just write out the algebra tiles, and this is what you're going to write in your notes. Pick a number. What algebra tile do you use to pick a number? Remember, everybody's number is different, so you don't know what number that is, so what algebra tile would represent that? Put that down. I'm not going to tell you what it is. You got to know by now. Add 2. That's 2 unit tiles. So add 2 unit tiles to whatever you first had. Now multiply that by 3. So if you had something plus 2 up here, now you got something plus 2, something plus 2, something plus 2, for a grand total of 3 somethings, plus over here you should have, hopefully you have 6 over there. Now of those 6 you have over there, I want you to take away 3 of them. So you no longer have something times 3 somethings and 6, you now have 3 somethings, and 6 minus 3 would be 3. Divide by 3. So you should have something. And let's see, 3 divided by 3 is 1. So you should have something, because you no longer have 3 somethings, because you divided by 3, you have 1 something, and you have a 1 over here. Subtract the original number. So subtract the something. Everybody should have 1 unit tile left over here if you did it right. All right, what was your something? That's right, it should have been an X tile, but I assume everybody had that. If you didn't, go back and fill this in and rewatch the video and look at that. Next one, question number 4. My computer's a little slow, we're catching up. Here we go. Let's reverse the thinking. Here is the algebra tiles. What were they doing over here? Well, think about it. If here's an X tile, what did they tell you to really do? Well, they told you to pick a number. Who knows what number that is? An X tile represents some mysterious number. What's different in this picture? There's what has been added to this picture. So write down, add whatever you see over there. Now you can see that there's not just one group of this x plus that, or x plus 4, there's 2 groups of it. So they had you do what to this one to get to this one. Write down your step here. I hope you wrote down multiply by 2. Then they subtracted something away right there. That should be fairly simple. Write down what they had you subtract away. Now we went from an 2 x's, actually an x plus 3 and an x plus 3, or a grand total of 2x plus 6, down to just only 1x plus 3. So we have half as much. How do we get to half as much again? We need to divide by something. So tell me what we divided by here. And then we got rid of these 3 unit tiles here. So we subtracted something to just have an x left over, or your original number. So put that down. I expect those will be in your notes when you come to see me tomorrow. Now, what you're kind of doing by reversing your thinking here, when you're going backwards and working backwards, is you're using something called inverse operations, when you do kind of the opposite. So, by doing the opposite, if inverse operations means do the opposite, what would be the inverse operation for addition? That's right, subtraction. What would be the inverse operation for multiplication? That's right, division. So what would be the inverse operations for dividing by 2? Hopefully you came up with multiply by 2. And what would be the inverse operations for subtracting 9? That's right, it would be adding 9. They use subtract, or this sign, they just meant subtract 9. Some of you are going to get that confused, but subtract 9, the inverse of that would be to add 9. Hopefully that makes sense what inverse operations are. We're going to be using those quite a bit more. Now, I want to go back to my original problem. Now, remember the first step I had was pick the first 3 digits of your phone number? It's like an X tile, okay? I don't know what your first 3 digits are. Actually, I do. I can look it up here and I can call your parents and make sure you're doing your homework, if you're not right now. But pick the first 3 digits, like picking an X. Then I had you multiply by 35. I'm not going to have you write this down, but you can see that would be 35 groups of that. Then I had you multiply by 300. So all 35 groups of that, I had you multiply by 300 more groups. Well, that's quite a bit. Then I had you divide by 7, which really all this did is it took this multiply by 35, and it took the factor of 7 away from that. So now it's like you only multiplied by 5 up here. So 5 up here and 300 here is 1,500 so far. I know it might be above your head. I'm a math teacher. I'm a math geek. Give me a break. Now the 1,500 up here, I had you multiply by 40. That gave me 60,000. I've now multiplied your number basically by 60,000 at that point. I then divided by 3. So instead of being up 60,000, I'm only up 20,000. That's a key. Then I had you add the last 4 digits of your phone number twice. So it's twice as, the last 4 digits are twice as big as they normally are. Remember, this was 20,000, this was twice as big. Then I had you divide by 2. That brought the 20,000 to 10,000. If you take your first 3 numbers and multiply that by 10,000, that moves those 3 digits over 4 spots and makes room for your last 4 digits of your phone number. And when I had you add this twice and then divide by 2, it's like I really only had you add it in there once. That is why your first 3 digits ended up in those spots farthest to the left on your calculator, and the last 4 digits lined up right where they should be. And yes, do you recognize the number on this one? It's your phone number. If you didn't get it, try it again. You'll figure it out. Anyways, we will see you tomorrow, and I was going to say good luck, but we've already gone through this, so there's no good luck. We'll just see you tomorrow. Bye-bye.